everyone. My name is Dash. I've been a research programmer at the Vancouver Genome Sciences Center for the past 2 years, helping out with CanDIG, mostly by developing our microservices and time to time tackling security-related issues. All right, can everyone see my screen?
Yep.
Okay. Oops. So this presentation is kind of an extension onto our previous CanDIG conference on security, as well as my experiences when creating a PR test for Keycloak. So I'll start off by kind of explaining what Keycloak is for anyone who may not be as familiar with Keycloak, and then we'll have a small talk on distributed authentication and authorization, and this will kind of explain what I was trying to fix within Keycloak and why this kind of matters for CanDIG and the GA4GH. And then we'll dive into the Keycloak Test Suite itself, talk about what the code architecture looks like, and some of the do's and don'ts when it comes to writing tests to make the Keycloak PR maintainers happy. So Keycloak is an open source identity and access management solution. What this essentially boils down to is that you can use Keycloak to add a layer of security to an application. Now, typically, this would involve allowing your users to authenticate to your application, but it can also involve a variety of different authorization methods. Now, in a single application, authentication and authorization are pretty straightforward to implement because your security software will have a database of all your users, and that's basically it. It'll allow people that are in that database and deny everyone that's not in said database. But for CanDIG, we have a bit of a broader problem to solve. One of CanDIG's core tenets is that it should be fully distributed. Now, what this really means is that each site communicates directly with each other, and there's no kind of high-level overseer that makes decisions for any specific node. So this means that each site has to be responsible for managing the identities of its users and what information they're able to access. This presents us with a situation where we can have a user that is affiliated with site A who logs into the CanDIG system, but then could ask site B for information that site B contains. Now, site B won't actually know anything about this user is affiliated with site A. So we have to have ways for sites to communicate authorization-related information between them. And we also have to have ways for sites to kind of verify that the information about this user is can be trusted. So if we remember back to Brennan's presentation last time, he talked a lot about claims, which, as a reminder, are just basically pieces of information included within a token that tell us things about the individual. Claims can be basically anything. Typically, they're things like usernames or emails, but we can also use them for authorization purposes. Now, as part of their AI specification, the GA4GH created this claim structure called passport. The passport is essentially a very, very large claim that contains many other authorization and authentication-related claims. Some of these claims within the passport allow services to verify the authenticity of data, either through the use of carrying cryptographic keys or routing services to endpoints such as data access committees, where they can confirm that this information is correct. Now, the internal structure of the passport is not exactly needed to know for this discussion. The passport itself is quite large and could be a presentation all by itself. The takeaway here is that in order for authorization to work in a distributed environment, we need to have these passports being shared between sites. Now, the way this is kind of done is through another security concept called identity brokering. I'm sure all of you are actually kind of familiar with this, you just don't know about it. But if we have a researcher who's affiliated with Site A and they want to log in to Site B, Site B doesn't actually know anything about this researcher. So what this researcher can do is actually log in using his Site A credentials at Site A, and Site A will then send this researcher's credentials to Site B. This authentication happens, and then Site B, in order to gain more information about what this user is authorized to look at, can send some cryptographic information to Site A's user info endpoint. And this user info endpoint will then return this researcher's passport. Once Site B has this passport, they can map some information about this researcher to their own database and determine if a researcher has access to the information they're looking for. Now, this user info endpoint is extremely important because this is what controls passport access as per the GA4G specification. And in Keycloak, this user info endpoint was not working. And when a user is trying to go through this identity brokering stuff, it's a very simple process. I'm sure everyone's actually seen single sign-on systems before, where you're able to basically use an alternate credential to log into a new site. And this is essentially what is going on here. Now, on the Keycloak side, when we make identity brokers, it's a fairly straightforward process. And what I want to focus on is this little toggle over here. What we found out was that regardless of this toggle being off or on, we were never able to access the URL we put in as our user info. So there was clearly something wrong with the code controlling this toggle, and thanks to Aman diving into the code, we were able to isolate the line that was causing us some issues. What we found out was that this line right here was a bit too stringent. So this line is after the toggle is checked, and then it then checks to see if the URL that I pointed to over here actually has something. And then it also happened to check to see if one of these 4 claims are missing. Now these 4 claims, the sub, the name, the preferred username, and email, are all very basic claims that would be created upon user creation in Keycloak. So unless you purposely take one of these claims out, they would always exist, and thus the user info is never actually being returned. Upon talking to Keycloak maintainers, they agreed that this was a bit too stringent and should just be taken out. So the fix itself was essentially just deleting this, and that kind of solved our issues. With that code gone, the toggle worked as expected, and things worked out. But showing that this fix actually didn't break anything was a lot harder, because Keycloak has a very vast testing suite with well over 1,000 unit tests, integration tests, and system tests. On my laptop, when I tried to run the entire test suite, I think it took close to 4 hours to finish. So that just gives you an idea of how long it takes. And being written in Java, everything kind of follows a very object-oriented approach to building the test classes. So if you're not familiar with the code itself, you can get lost trying to understand where functions can come from, because they've been inherited from classes that are like 3 levels up. The maintainers also don't add too many tests to Keycloak because their test suite is already so large, so you have to kind of focus your tests down into the bare minimum. And if you're unfamiliar with the code you're working with, it takes a bit of work to kind of set up an environment within your test class to get the program to the point where you're trying to actually test things. So if you have the unfortunate need to write a PR in Keycloak, the area that the test suite is located in is down below, and you will be taken to an area that has folders for basically every single part of Keycloak. Now, the part I was fixing was in the broker section, so I naturally went to there, and that contains a number of abstract test classes that you can extend to create your own test class. Luckily for me, I had some test classes that were similar to what I was doing, so I used those as a guideline to create my own test class, which is this user info claim to role mapper test. Now, to kind of demonstrate that the user info endpoint was functional, my aim was to show that Keycloak would be able to map information from the user info to its own data about the user when that user logs in through an identity broker. This is very easy to do when you're doing it through the GUI, but it took a bit of work to figure out how to do this in the actual test code. So when I say a mapper, I'm talking about this little GUI over here. Basically what happens is that Keycloak looks for a claim called GA4GH password v1. If it finds this claim, it'll then create its own claim called GA4GH passport, and then just copy everything within this passport claim to its own claim about the user. And I have it set here to check the user info. Figuring out how to do this within the Keycloak test code took me a fairly long time, just due to the fact that this kind of stuff isn't actually documented anywhere. It's more if you have to look through test code until you find something that you think is usable and then mess around with it. But this essentially creates the same type of mapper that I was creating over here. Now, once everything is kind of set up and you have your virtual brokers and systems set up within your test class, it's very simple to actually write tests. Since the tests are very sequential in their nature, this one, for example, this creates the mapper I was just talking about, and then it creates a user in the provider realm. So if you are doing broker testing in Keycloak, rather than creating, entirely new Keycloak instances, you can use different realms within Keycloak to act as, for one to act as an identity broker for another one. So we created our user in the provider realm, which in this case would be our site A, and then we log in with our user as in our site B. And then what this does is we just then check to see that in site B, we have our user logged in and they have the information that's mapped from site A to site B. Now, originally I wrote around 10 tests to kind of check all the different fringe cases that may occur through using the user info endpoint. But after the maintainers finally checked it, they thought only 2 were sufficient. So that kind of gives you an idea of how many tests they're looking for when it comes to PRs. And that's essentially it when it comes to writing tests in Keycloak. If anyone has any questions, both about test itself and more security-related things, I'm happy to answer any questions.
Thank you, Dash. That was great. Does anyone have any questions?
Maybe I'll start if no one else has a question yet. Dash, what was it like just sort of setting up the dev and test environment for Keycloak? It sounds like there was a lot of work involved in trolling through the code to figure out how to add the test. Was setting up that dev and test environment relatively straightforward, or was that a little arduous too?
Well, the test environment itself, running tests and stuff, is not that difficult. It's more of getting to the point where you have Keycloak at a stage that you want to write your tests, that you want to test at. Like for me, it was getting to the point where I had a broker within my code and having the code being able to log into the broker and map the information coming back from the broker to my second instance of Keycloak. I think that it really depends on what you're doing. Broker testing is definitely a bit more of a complex task compared to hitting something within like one instance of Keycloak. And that's where a lot of my troubles came in, just trying to do that within code versus doing it with, two actual instances of Keycloak running and then just testing it by hand.
Cool. So it was the, again, besides just figuring out the code, it was more about like the infrastructure part of it, of having both Keycloaks up and running and ready to go.
Yeah.
Yeah, cool. Really interesting thing.